So yesterday we talked about different transformations, and today we're going to apply those to real world applications. Okay, so the first one's about a home library. The number of books in Hannah's home library can be described by, and then they give you an equation called n of x, and it's equal to 4x plus 2. I like to highlight things like that because I know it's going to be important. And then it says where x is the number of months that have passed since she began expanding her library. And then what we have to do is describe how n of x is related to its parent function. And then we're going to interpret the function in context of the situation. So we're doing two different things here. The describe we did yesterday, okay, how it's related to the parent function. And then we're going to do some interpreting, which we actually did in some of our earlier sections. Remember how you had to interpret the intercepts in terms of the situation, the x-intercept and the y-intercept? We have an example about a gift card. That's going to be similar. So we're going to do the first one together. So if we're describing how it's related to its parent function, we need to know what the parent function is. Because you have x to the first power, this is going to be linear. So you can think of the parent. In this case, we're not going to use y equals. They give you n of x. So this would be n of x equals x. That's what we're going to compare it to. Okay, so if you're looking at this equation, n of x equals 4x plus 2, okay, we talked yesterday about how the plus 2 means you're going where? Yep. Do you guys remember what the first number tells you? The 4? Yeah, it's going to be it's the dilation, it's the slope. We're going to talk about both of those. So the dilations can either be vertical or horizontal. For linear, if it's in front of the x, do you guys remember what it is? Vertical. Yeah. And then you just have to compare that to 1. So if 4 is greater than 1, it's a vertical stretch. So the first part of this is exactly like what you did yesterday, where you're going to say n of x equals x is vertically stretched. And we're actually going to add in here what it's stretched by. So if it's 4, it's vertically stretched by 4. And is translated to units up. So that's the first part. That's the description. N of x equals x is vertically stretched by 4 and is translated 2 units up. That's how it's related to your parent function. Now we have to interpret that in context. And I'm glad that some of you already mentioned that 4 is going to be the slope because that's going to be part of our context. Okay, and this 2 is called the what in a linear function? The y-intercept. Do you guys remember when we were describing the y-intercept with tables, what the y-intercept represented? It's going to be where x is 0. And then when we were writing out the sentences, do you guys remember what we usually said about it? Yeah, it was the initial amount, okay? So that means, in this case, let's go back and let's reread this so we know what the situation is. So we have Hannah's home library, and they talk about the number of books in her home library can be described by this. So this is your output, the number of books, and your input is x. And we know that x in this case represents the number of months that have passed since she began expanding her library. So that means in my description, I'm going to have to talk about the number of books, and I'm going to have to talk about the months. So those are the units that I want to include. Okay, so if the y-intercept is 2, That's the initial amount. So Hannah starts with 2 what? 2 books. Okay, so we have to just quantify that with our units. Okay, so Hannah starts with 2 books. Okay, now it says X is the number of months that have passed, and I see that the 4 is attached to the X, which is your slope. Do you guys know what that means? Exactly. So she gets 4 new books every month. So Hannah starts with 2 books and adds 4 books. Each month to her collection. Okay, so this is where you need to make sure that you're talking about the units. So what does the slope represent? The 4 books. What does the initial represent? The 2 books. And then make sure you explain that this is going to be each month based on your X value. All right, nice work. All right, we're going to try the following object one, and I'm going to give you a moment right now to do the first part. So I want you to read through this, identify what the parent function is, and then I want you to just do the first part. I'll help you with the context part. Okay, so at this time, I've expected you to know that the parent function is quadratic. So you would start with h of x equals x squared. Okay, and then let's talk about the different transformations. Remember, the negative is going to be the reflection. So it is reflected, and if you don't see any parentheses, we think of it as it's on the outside, so that means it's reflected over which axis? Yep. Okay, the next thing that's different from the parent function is the 16. And again, there's no parentheses that's inside, so that's going to be a vertical transformation. It'll be vertically stretched because 16 is greater than 1. So it's vertically stretched by 16. And you have the plus 80. So it's translated 80 units up. Now you can write these down in any order that you want. So if you did the vertically stretched and the translation but forgot the reflection, you can just add that in at the end. Okay, now whenever you have a quadratic, we're going to have to do an analysis that's a little bit different. So when you have a quadratic function, this is talking about the height in feet of an object that is dropped from a platform. Okay, and x is the time that has passed in seconds. And when you have a quadratic, we know that it's going to form a parabola. So because it forms a parabola that's opening down, and I know it's opening down because of the reflection, right? That negative means it's opening down instead of up. The vertex is going to be a maximum, okay, a max value. So we've talked about local maxes and local mins. Okay, this is just a maximum because it's the highest point on your graph. And so what we're going to do is we're going to analyze this part of the situation. So you're going to tell me which way the parabola opens. And in this case, the parabola opens down or downward. Okay, the parabola opens down, so there's a maximum something. Okay, so the maximum is going to be the y-coordinate, and the y-coordinate is the same as the output. So the y-coordinate is going to be the height. Okay, so the parabola opens down, so there's a maximum height in feet represented by the vertex. Okay, so you are going to explain what that vertex is. Okay, and then we are also going to explain what this plus 80 represents. And I'm also going to show you this. Okay, so normally when you have a parabola, this doesn't give you a model, but it says that it's dropped from some platform. We don't necessarily know where it is or if like they're throwing it up and down. So just depending on what your platform is, a lot of times when you see an object being dropped, you'll have an X and a Y axis. And this is going to be where it hits the ground. This is going to be where it reaches the maximum value. And this is going to be where it starts, the initial value. So in this case, our initial value is what? What's our y-intercept here? 80. Okay, so what we're going to say is the translation of 80 units up represents the initial height of 80 feet. The translation of 80 units up represents the initial height of 80 feet. So what we've done in the explanation is we've talked about the negative, how that affects the parabola. It opens down, it creates that maximum height, okay, with your vertex, and then the translation of 80 units up, that's going to be where the object starts, okay, at 80 feet. All right, and then the last thing that we're going to do is write equations for functions. When you're writing the equations, it's really important that you're showing your work, especially when we get to parts B and C. The linear might be pretty simple for you. Okay, so if I asked you to write an equation of this line, do you guys think you could do it? Is that me telling you? So we know every line has to be in what form? Yep. So y equals mx plus b. So what would you guys find first? The y-intercept. Yep, your b value. Okay, so that's pretty simple to pick out on the line. Your final answer, you should have something plugged in for m and something plugged in for b. Okay, so your b value, we'll just count 1, 2, 3, 4, 5. Okay, and then how are you guys thinking that you'll find your slope? Okay, yep, we could use rise over run, absolutely. And then just pay attention to what direction this is going. Is it going up or down from left to right? Down. So that means you should have what type of slope? Negative. Okay? So we just have to find another point that's exact. So you could use this one, you could use that one, and then you just might have to reduce. So you would go down 1, 2. The rise is up or down. If it's down, it's negative. And then you could do the run, which would be 1. Okay, and then because you're going to the right, so then your slope would be -2. Is there another way you guys remember finding the slope? I mean, that's the way that I would do, but that's not the only way. You can always find the slope when you have 2 points, right? You guys remember the slope formula? y2 minus y1 over x2 minus x1. You could do that as well. So you could do the rise over the run, or you could pick 2 points and you could do that. Up to you, okay? All right, for B, sorry that prints so nicely. You have a V-shaped graph, which means it's what? Absolute value. Just going to make that a little bit more visible. And yesterday we talked about the absolute value standard equation. I did leave one little part off though that we're going to talk about today. Okay, so in your absolute value equation, if there's a stretch or compression, there's a value on the outside that we call A. So we're just going to add that into it today. And remember we talked about how HK is the vertex. And then that negative really means the opposite. So your first step is going to be to find the vertex. Okay, so all we have to do is look at our graph. 3, 2. Okay, so then what we're going to do is we're going to plug 3 in for H, we're going to plug 2 in for K, and we're going to solve to find your slope. Okay, I'm going to put step 2 here. So each side of this is a linear function. This is linear, this is linear. Okay, it's a reflection of that. Your slope in this equation is A, which I know feels a little weird because we're used to slope always being M, and change is hard, I know. I don't like it either. I wish it was always M, but they use A, so I'm just keeping that the same for you. Okay, so the H I plugged in, so it's x minus 3, x minus H. The plus K will be plus 2. And then if I want to find A, the slope, you can just do the rise over run again. And if you look at this, all right, so we're just going to do the rise over run. And it honestly doesn't matter which one you do because the direction is going to tell you whether it's positive or negative. So if you do the rise over run from this point, we'll just find another point that's at the exact place. So you can either do it from here or from here. I think this one they actually showed you. So you would be going up 1, 2, 3, 4, 5. So your rise would be 5. Your run in either direction would be 1, which would give you 5. And then you just have to adjust for which way it opens. So it'll be a positive slope if it opens up. Okay, so if you had a V opening upward, which we do, and then you would just change it to a negative if it opens down, because that's when you would have the reflection. Okay, so our A value is going to be positive 5. And then your final answer is going to be f of x equals 5 absolute value of x minus 3 plus 2. So it's this exact equation, but you're going to have the 5 plugged in. And the direction it opens is going to tell you whether your A value is positive or negative. All right, and then the last one is a quadratic. So just like with the absolute value, the quadratic standard form has an a value in front. So it's f of x equals a x minus h squared plus k. And we talked about this yesterday, but that a value in front, that's going to change if you have any type of vertical stretch or compression. And our first step is going to be the same. So your first step, you are going to find your vertex, which is HK. When you're finding that on the graph, this is 0, this is -2, so halfway is -1. And then this goes -2, -4, -6. So this is halfway. So your vertex is -1, -5. Okay, so we're going to plug in HK. So we'd have f of x equals a times, and then when you have minus a negative, it's going to turn into plus. So this is x plus 1, and then the plus k, because that's a negative, it's just going to be minus. And then to find the a value, we are going to find a point. Okay, and it can be any point on there. We're going to try to find an exact value that's on the parabola because we know that that fits the equation. And we're going to plug that in to solve for a. So we're going to find a point, xy, on the parabola. And we're going to plug that into your equation, and we're going to solve that for a. So I want you to find a point right now on the graph. There's really two of them that you can use. And remember that any point you find is an x and a y. So when we plug it in, we're going to plug it in for x and y. So what point did we find? Yeah, 0, -7 is great. And some of you may have found its friend, -2, -7. So it honestly does not matter which one you choose. Okay, you can choose either one of those. So if we do 0, -7, I'm going to plug in 0 for x and then -7 for y. You might not always find one that's the y-intercept, okay? And then we're going to substitute that into our equation. So y is the same thing as f of x. So it's -7 equals a 0 plus 1 squared minus 5. And then you just have to follow your order of operations. So do what's in parentheses, then square it. You'll get a times 1 minus 5. Okay, and the reason why I'm showing you this is it's not always just going to be 1. So you might have to do some division there. And then we're just going to solve to get a by itself. Okay, and then once you've found that, you're ready to write your final equation. So -2 x plus 1 squared minus 5 Okay, so make sure that you don't keep the x in there. You should always see the x and you should always see the f of x, okay?